everyone. My name is Nordby. I'm a software and electronics engineer. Today I'm here to talk about black boxes and why we need to stop making them. So our open source hardware devices are developed in the open using collaborative models, using open source technology. The source code, the schematics all end up on GitHub or similar sharing services, which is all great. However, to the end user, when you receive an open hardware device, perhaps produced by someone else than the person who designed it, it often ends up in being the same kind of device as a closed device. It's a thing with fixed functionality when it's very hard to change what it does. You could go and redesign the whole thing if you were a software engineer or electronics engineer who knew all those things. But to the end user, a person who doesn't have those skills already, this is not much easier than a closed source device. So before I go to say what I think we need to do about this, I would like to say that we've been here before. The free software versus open source software debate has been a big thing a long time ago. To me, what it comes down to is thinking about, okay, the freedom that we have defined, the 4 freedoms of free and open source software, who is it for? Open source software, which has been massively successful, is about the freedom of the developer, of the manufacturer. The freedom to take the piece of code that you have received, use it for any purpose, integrate it into any device, product, and so on, in an open, collaborative way, because it's a better way of developing. And today, huge companies like Facebook, Google, Twitter, Samsung, Intel, they all use open source. It's massively successful. It's no longer a question of if you use open source, it's a question of how much you use. And on the other hand, free software has not been so successful. You, as users of Google, Twitter, and so on, know that even though they build all their stuff on open source, it doesn't make it you more in control. It doesn't make it your privacy more respected or easier for you to learn or hack it. It is simply a developer freedom thing for them. So this is relevant for open source hardware because of 2 things. One, the open source hardware movement kind of grew partially out of the open software movement. And 2, because of embedded devices. Today, almost every electronic device includes a microcontroller. There are billions and billions and billions of microcontrollers shipped every year, and actually most of them are not in computers. Most of them are not in smartphones. They're in everything else that we have around us. I'm sure every speaker in here has 2 microcontrollers or more. Your car has 50, and so on. So software freedom is important, and it's important that we don't make the same mistakes in focusing only on manufacturer and developer freedom if we are to be able to achieve end-user freedom of those devices. When it comes to software and the importance in devices, Cory Doctorow went so far as to say that we don't have airplanes, we have computers that can fly. We don't have cars, we have computers that can drive. More on a hacker level, we know that you can make a toaster oven into an S&D reflow oven if only you change the temperature curve defined by the software. So another reason this is very important is because of the increased importance of electronic devices in our lives. There's a lot of talk about digital divides, and mostly talk about the first level digital divide, which is access to information, and especially the internet. There's also a second level digital divide, which is that of creators versus consumers. Creators being the ones who have the knowledge and faith in themselves to create and shape technology for their purposes, and consumers being the ones who are merely forced to choose between options A and B, which neither might do really what you want because you don't have that power. Open source hardware is our way of trying to deal with these problems, trying to bridge that digital divide. And here's a typical device I just picked on from a list online called Bumpy. It's an MP3 player, similar to an iPad Nano or so on. And if I wanted to make a change to this device, or even understanding how it works, even if I disregarded the hardware bits, which would require me to have some sort of manufacturing tools, soldering equipment, and all that, even if I focus only on software, This has a microcontroller which controls all the buttons and what they do, the user output, the LED, and so on. I would have to go online, search for the product. Maybe I didn't get it from a person who knew what it was, and try to find that source code, and then download the build tool chain so that I can start trying to develop for this device. I'll have to learn C or C++ to grok the code. And this is a process that takes a long time. If you didn't have all these skills from before, it would very quickly be manageable. I think this is why we don't see a lot of people actually taking control of devices. So I like to think about this in terms of not user versus developer, it's a continuum, and engagement. So most people, this includes most of us, with respect to a given device, we are consumers. We use it as is. And that is in a way fine, but there needs to be a way to kind of to choose to be something more, if you so desire. Most people are consumers and engage very little. They exercise very little control over their device, whereas the majority of our devices are created by engineers and established electronics departments. We have tinkerers and hackers and entrepreneurs in between, but they're relatively few. And current open source software thinking focuses mostly on those who are already at least hacker and then kind of go on to engineer. But what about how do we get people in there? How do we get more people in? So I think we need to smoothen the transition. We need to make tools that make it easier for consumers and more motivating for consumers to get started, play around with your device, see what's going on, and change it. So here's a little demo. It's from a video. We only have picture slides of a product that we've been using, an open source tool we've been developing for the last year called FlowHub. And here we have a Raspberry Pi running NoFlow, which has a PID motion sensor attached to it, some LEDs, and a webcam. Now, when I want to hack this device, or I want to see what's going on, because I'm curious or whatever, I can tap the NFC tag, which is attached to the device, with any NFC-enabled thing, like my Android tablet. There's no special software installed on it. It will download an IDE from the internet, open that in the browser, automatically connect to the running program of that Raspberry Pi, and show it to me. So I can go and see, what is it actually doing? Okay, it seems like I have a motion component here, which listens to the GPIO. It's sent through some components to a file name, and then there's something called camera, which is of the type grab webcam. So I can kind of infer that maybe when the motion sensor changes state, it will take a picture. And I can now press one of the connections between these nodes, and I can look at the data flowing through. And then I could try to trigger the motion sensor and see if what I assumed to be true was true. And if I wanted to, I could live rewire the graph and do something different with it. Maybe I didn't want to take a picture. Maybe I wanted to hook up something else. Maybe I want to send a tweet. Maybe whatever. You can also change the components themselves. So what makes me especially excited about this tool, that it's open source, and also that we use a standardized protocol to communicate between the IDE, your programming tool, and the device and the program that you're connected to, which means that we can program not only Node.js, which this Raspberry Pi ran, but also JavaScript for browser applications, microcontrollers like Arduinos and so on, Java for Android or your normal computer, or even specialized tools like image processing. And this, I think, is one of the type of tools that we need to develop if we are to create open hardware devices which are effectively open to end users. So I would like to say, death to black boxes. Thank you very much.